Welcome to Martin's Institute of Teaching. In this video we're going to be working with binary numbers again. This time we're going to be converting from binary to octal and from octal back into binary. So let's go ahead and get started. So octal numbers, they deal with numbers that are base 8, which means that they start with a 0 and they continue all the way to 7. So, and as soon as you get to 7, then you start over again. So when we were dealing with binary, it starts with 0 and it continues to 1 and then it starts over. When you're dealing with, so this would be base 2. When you're dealing with base 3, it's from 0 all the way to 2. When you get to octal or base 8, you start with 0 and you go all the way to 7. When you get into hex, which is base 16, it starts at 0 and it goes all the way through 15. So what that means is, for our system, our base 10 system, we start at 0 and we continue all the way to 9 until we start recycling the numbers. So for the normal system that people use every day, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then when you get to 9, it starts over with a, well, actually writing it this way doesn't, you can't see it so easily. So it's easier to write it vertically. So if we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And here's where we recycle the numbers. And we start with the 0 here and we add a 1 to the next spot, which is the tens place. Now, when we're dealing with octal or base 8, we start with 0 and we proceed all the way down to 7. When we get to 7, that's when we start recycling the numbers. So we get a 0 here and a 1 there. And we keep recycling the numbers until you get to 17. As soon as you get to 17, we increase the, well, I guess it's considered the 8's place. And you go to 2, 0. And you continue with this pattern. Just like when we count from 10, we go to 19, and then we increase the 10 spot to 2, which makes 20. All right, so I think now we're going to go ahead and let's just get started with actually converting some numbers. So first we're going to start with binary, and then we're going to convert that to octal, and then from there we'll go from octal and into binary. So let's say we have this binary number, which is 1, 1, 1, 0, 1, 0, 0, 1, 1. Okay, so actually let's just start out with smaller numbers first. Okay, so we want to convert this number into octal. So when we convert a binary number into octal, you go by 3 bits at a time. So this first bit, well, we know in binary, if we wanted to convert this into decimal, we would have to find the value of each of these places. But for octal, you're actually converting this only the first, in groups of 3. So you get this first group of 3, and then you get the next group of 3, and you just continue on in the same pattern until you run out of values. So here we have 0, 1, 1. So this is going to be 1, 2, that's 3. And this value is just 2. So in octal, this binary representation would be 23. So I would write this as 23 and put an 8 here to represent base 8 or octal. Now let's go ahead and convert this binary number into decimal. So if I wanted to convert this into decimal, well, then I would have to start with each of these places. I know that this is going to be, well, let's start with this one. So this is 0, 1, 2, 3, 0, 1, 2, 3, 4. So that's 2 to the 4. Well, it's 1 times 2 to the 4. That's this one times 2 to the 4 plus, so that's 0, 1. So that is 1 times 2 to the first power plus 1 times 2 to the 0 power. And this is one way you can convert them if you don't have these all memorized. So this is 2 to the 4, so let's see, 2 to the 0 power, 1 times 2 to the 0 power is just 1. 1 times 2 to the first power is just 2. And 1 times 2 to the fourth power, 2 to the fourth power is 16. So this value here would be 16 plus 2 is 18 plus 1 is 19. So it would be 19. But when we write this in base 2, we'd say it's equal to it's equal to 19, and then this would be, actually this is decimals, or decimal, which is base 10. So this binary number in decimal is 19. Let's see. Let's see, what else do we want to do? So let's see, why don't we go ahead and now convert a number that is 1, 2, 4, 8, 16, that's correct. Okay, so now let's go ahead and take a number like, let's say 426, and this is base 8. So if I want to convert this into a binary number, well, first number I deal with, this is 2, this 4 right here, and I know that 4 is 0, 1, 0, because this is 1, 2, well actually no, sorry. 4 is represented by 1, 0, 0, which is 1, 2, 4. That is its representation. Next we get this next value, which is 2. So, and 2 is represented by 0, 1, 0. And next is the 6. So 6 is just 1, 1, 0. So this value 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 1, 0 in binary is equivalent of writing 426 in octal. Now, if we wanted to convert this into decimal, well, then you just have to go through here and figure out which each of these positions is. So this is, let's see, this is 1, 2, let's see, plus 2, plus 4, 8, 16, 32, 64, 120, 256. So we would just add these values together. So that's going to be, let's see, 16 plus 4 is 20. Added to here, that's 276. So this is 278 in base 10. So 426 in octal is the same thing as saying this one with this value. Well, all these numbers represent 426 in octal, but this is binary. And if we convert this binary into decimal, which is base 10, we get 278. So let's see, let's go ahead and convert another one. Let's see, what should we do now? So we've gone from octal to decimal, no, octal to binary, then we went from binary to decimal. So here we went from binary to octal and binary to decimal. So let's just do one more. Let's say the value of, let's just go from octal, no, actually let's go from binary again into octal. So let's say 111, 101, 100, 001. Okay, so if we want to convert this value into octal, remember again we just group them in groups of 3, like this. So this first one, that represents a 7, this represents a 5, this represents a 4, and that's a 1, and this is an octal. So that is for that value, that is that value. And this is how you would convert from binary into octal. And if you wanted to go the opposite way, you just do the same thing. You convert this into binary in clumps of 3. So I'm not quite sure what else to do with this. If you guys want more information on it, or if you want something specific, just add a note into the comments below. And I'll try to make a video on it as quick as I can. But for now, I'm kind of short on ideas on what to do on this. So yeah, if you guys have any more questions, just let me know. So I hope you liked the video. In the next video, I'm going to show you guys how to deal with hexadecimal. So stay tuned for that. All right, thanks for watching, and good luck in your classes.